Oh, hello. While I wait for a couple people to get online here. Getting texts here. All right. Let's see. There we go. Hello. We got Sean, Joe in line 4, and David Prado. I'm kind of waiting for a few people to show up here. I'm cleaning a board for an old junker amp here. I was just cleaning on it. We're going to get ready to start. So I had 3 Rockfords up on the thing. I had an old one, which is a 501S, and then I've got 2 Rockford punches, a P400-2 and a P200-2. Anybody got any preferences? And can you hear me? Yeah, loud and clear. Thanks, Joe in line. All right, this is old Visonic I'm fixing up for a buddy. It's just kind of a junker amp. Came out of the junker pile. It's nasty. It was in the shop, and it is filthy. And it's got my hands all sticky. Okay. So newer Rockford or the older Rockford? What do you think? I know everybody's going to want to say older Rockford, but the newers are explainable too. And I'm not sure what's wrong with any of them, so we may open one up and say, oh, this is a blooming mess. Let's pick something that we can do a little better job of repairing. So I'm gonna stream for an hour or two anyway. I'm out here. I've been working on Xboxes and stuff, and I'm tired of that. I'm ready to go back to an amp. So, and I got some parts in for some of these Rockfords. I was out of parts for a while. I'd used them all up to fix a few. So, how long am I going to live stream? At least a couple hours. I hope to get a couple of them fixed. I hope to fix all 3 of them, but live streaming and recording always makes it take a long time. So, if they all go well, we'll just do them all 3. Chappelle Tapak, is that how you say that? It feels like it'd be French or something, but Chappelle. I can butcher a name really good. I can promise you that. So let's do this. Let's just start with a small one and take a peek at each one. My overhead light's going to glare off this cover. This is a P200-2. To open them up, you need a T10 Torx to take the cover off. And we're just going to peek in all 3 of them real quick, and then we'll work on them. And if everything goes good, I might live stream again tomorrow too. I'm a Kansas City Chiefs fan, and so they play late in the day, so I could probably get, if we don't get these done tonight, probably go again. I know that might be in the middle of your team playing, but Hey Cliff, it's Strictly Amps. You still doing repairs right now, or are you so booked up that that you're not taking any in? Okay, so that gets the cover off. That's these 4 screws. We can take the light pipe off, set it aside. We're going to get our multimeter, and we're going to get on continuity. And we're going to go, the middle is ground, so we're going to put our black on the ground, and the red is positive, and that's over on this terminal. And we're going to watch to see if these input filters caps completely charge. And we're getting a whole lot of nothing. Let's make sure they're discharged. Let's try that again. There's no fuses on this amp, so ground and B+. There we go. It's charging up. They already had a little charge on them. So what that means, if these will charge, this is where your battery and your positive and negative go in. If these will charge, that normally means the stuff that's in the power supply circuit doesn't have anything wrong with it to the point that would pull down and cause current draw if you was to hook power up to it. And so that's what we're looking for. We're wanting to be careful there. And normally it gives you maybe a 70% chance or better, maybe even a little higher, that at least the power supply circuit's working. So we're going to go over now, and this is a 2-channel amp, and so that's going to be the left channel and the right channel. I love how these Rockfords are laid out. Oh man, Cliff, you're still working every day. After tonight, you're off for 8 days. Come on, 11, no doubt. Sweet. Yeah, I've got an extra day on the weekend because of Thanksgiving coming up, and then I took a few vacation days in between Christmas and New Year's to give me a long break there, so that's going to be fantastic. But I'm going to have to get my spectacles out here because I'm looking. What I'm looking for is burns on these source resistors, and then to make sure that the solder joints look factory. Oh, I can already see something. I'm going to, and I mean it's big time. It is exactly, it may be the whole thing that's wrong with this amp. Man, I don't, my other camera screwed up, and so I don't have one to move around. I got one to look, got it all mounted up to look at my oscilloscope. So I'm not sure if I can show you this. I might be able to do that trick with that, but if we get in here, oh yeah, I think I can get it. Do you see what I see? Right there. See that piece of wire? That is touching the heat sink and the leg, which is one of the switching legs. So that's part of the reason why I look inside these, is to look around. So I'm going to take that piece of wire out. I don't know if you can see that, if I can get that. It's that little tiny piece of wire. Boy, that's all it takes to cause problems. And I see some more over here. So there's another piece, so I need a paper towel. So I have opened up a lot of these Rockfords where they didn't work or something went crazy, and found, there's 2 that I found already. Right there, bam. Found wire strands. For some reason, Rockford's terminal blocks are a little bit bad about somehow letting wire through. I don't know. I don't know if it gets in around the edges, or if it can get in under this cover kind of easy, or what. So that means this amp may be good. We're gonna let's check these FETs real quick. So we're gonna check the power supply FETs just for giggles to make sure none of them are shorted. And if you get a beep and it goes away, that just means it's charging up caps and it's not actually shorted. So you You can get that and it's good. So whenever you've got your multimeter on there, leave it on there for a second. If it goes away, that's a good thing. And the only thing wrong with this one could be a whole bunch of those wire strands all over the place. And you have to take them apart and clean it everywhere, because you got to look underneath, you got to get the board out and everything else. So my thought is that we skip this one. Oh, David's still using his Rockford Fosgate 1000.1 from the mid to late 90s. Awesome. Chapol needs his T1001 BD to repair. So there's a couple good shops out there on the West Coast that specialize in Rockford. GS Amp Repair, which is George Sanchez. He is in Arizona. Does awesome job. He's a former Rockford tech. There's also in Arizona is Desert Audio Specialties, and they hire in on their spare time some of the Rockford techs to fix Rockford amps and stuff. So that's two good places I know. That's close out there on the West Coast anyway. I don't know anything in California, unfortunately. So my thought is that this one might be good. Might not be a thing wrong with it if it gets completely taken apart and cleaned. That's kind of boring. So let's say we skip it. I will. Not a problem. I hope I haven't butchered your name too bad. You could put it up there and tell me how much of a big goober I am for hacking your name. But I'm going to go on ahead and put the screws and that in the baggie, and let's switch to another one. Because watching somebody clean an amp is boring, but like I said, right off the bat we found those, nothing checked, shorted right off the bat. So what I'd do is I'd take it all apart, clean it, find all those wires, get them all out of there, and you have to go over it. I go over it anyway. I don't know if everybody has to go over it, but I go over it with a fine-tooth comb, because you never know when someone gets wedged under a cap or part of the coil or something. Sometimes the fault will actually cause these things to weld themselves to the thing, and that's part of your fault. So you kind of got to look everything over real good, clean it up, stick it back in the heat sink, and then I'd give it a test. So that may be all that's wrong with it, is that this one's been having issues with pieces of wire. When you do your installs, keep everything nice and neat and clean. Don't overcut into your wire. I recommend using ferrules. That helps knock down this issue. So this one, the cover is already off because the screws were missing. Somebody had already been into it when I got it. So let's give it a quick test. Let's make sure. If you have a big amplifier, do not short your battery to ground to discharge the caps. Use a resistor. You'll see in my videos that I use my little discharging resistor. And I just go from B+ to ground, and that'll drain the little 12 volt there. This has been rubbed off. I think this is like a 360 ohm 5 watt resistor. I use it for a lot of draining. But let's go ahead and put ground. And that. Oh, well, shoot, I can look down in here and I can see blackening of the power supply area. So, and you notice it won't charge those input filter caps. It's not going all the way up. So bam, we definitely know we got a bad power supply. So that's good. I get a lot of questions about bad power supplies. Everybody use my trusty Harbor Freight glasses. That's what these are. These are the yeah, I've got it right here. The little 5-piece eye-loop set from Harbor Freight. Crazy handy. Super cheap, but gives you, I've bought 2 of them. These are, several of them, and stuff that I keep around, because I don't have one of those fancy magnifiers to do circuit board repair under it with the camera set up like you see on some channels that do repair, like Lewis Rossman and all that. One of these days I'd like to have one of those, but I don't have it. So I'm going to go ahead and peek around here a little bit so we can see black there in the power supply FETs over here. Let's just see about these two channels here. That one appears shorted. So appears this channel has been shorted. You need a T15 to remove these screws and remove the screws from the board on this style Rockford. Yours is more of a headset. Yeah, I had one of those and I really hated it. I really hate things too heavy on my head. I'd like to find a good one or something, but I really want the microscope on the desk. So David says, I also have a Punch 200 DSM, and when the remote wire is connected, it blows the fuse. What can it be? Well, it's trying to power up, and it's probably going to be either a shorted channel, so the power supply comes up, and then the shorted channel causes too much current, and that pops the fuse, or the power supply is bad. So what you need to do is exactly what we did, is disconnect your amp, either let it set and drain off these caps, or use a resistor, and then test it like I did with my multimeter to see that, and then get in there and pull the cover off. You say it's a 200 DSM. Give me 1 second. This is a 200IX, which came out a little bit later. This thing's blown. It may be just parts, but you know, this is the power supply side, and this one's definitely blown. So here would be your battery terminals. That's where you would do your check, and then you're going to go through, and I show it on all the videos where we're doing it. Now it can be blown toasted like this. See all this blackening? I already started cleaning it away. A lot of that's just soot. So sometimes the damage isn't as bad as you think it is. So you can go in, and sometimes it is as bad as you think it is, but you can go in and you can clean all that blackening off on a lot of them. This one's been here so long. This is maybe a parts amp. I don't know. I just grabbed the first 200 I could see. So anyway, you're going to put it on continuity, and you're going to go through and check FETs for shorts. And these may be all blown open. Make sure my meter's in there. So right there, that FET's totally shorted. The beep doesn't go away. And so you're going to look for that, and you got to figure out what's the output and stuff and what's the power supply. So on the 200, it'll be somewhat similar if yours is just a straight up DSM. Here's the power terminal. So here's the inductor. So these are going to be the power transistors, and most likely these are IRF Z44s. They'll be something like that. And then in the output section, it should be IRF 540s and 9540s. So you should have one channel over here and one channel over here. These over here, two of them are going to have diode symbols. They're going to be double diodes. So that's the rectifiers. So when you do the switching and make the AC, this rectifies it. These caps smooth it into your rail voltage for your outputs to use. And then these two should be your regulators, an LM337 and an LM 317 for your plus and minus voltage, and that is for all your opt amps on your preamp section. So you can test all these FETs out here for the outputs, one channel each, and the FETs in the power supply. Normally you don't have to worry about these. That's really much more advanced. But that'll give you a rough idea with just your multimeter of how bad your amp is blown. And it'll give you an idea of probably more what it's going to cost to repair it. If you've got a bunch of blown channels and the power supply is all blown and everything, obviously it's going to be more expensive than if everything checks good on everywhere except for one channel. Like on this amp, if the power supply had stayed good but we only had this one channel bad, less expensive repair. Still a lot to do in that channel, and there's a lot of things you got to do right, but definitely less expensive. So we're going to continue to take this apart. Hope that helps. So one thing, depending on how old the Rockford is, I have to look at the schematics and stuff to give you 100%, but I will show you a neat trick when we do this power supply here that you can do for all the Rockfords from the second generation punch, like punch 45, punch 75, punch 150, the generation where it looks like the HD of the same series, but it's the one before. All the ones that have the TL494 pulse width modulation chip in it for the power supply section, you can, on a Rockford, hook up only ground and only remote. Leave the B plus completely disconnected, no power to it, and turn it on, and it'll actually power up the pulse width modulation chip, which would make the power supply start making power if the B plus was hooked up. And you can check the waveforms and see if the the power supply drive circuit is still actually working, which helps immensely to while you're trying to rebuild a power supply, because even once you've rebuilt it and put new FETs in, you can do that, and with the FETs in and stuff, you'll be able to see if the drive is not a nice square drive, if it's all funky, and you'll know you need to repair some more stuff before you actually put power to it. So that's the whole point of this. We're going to go with, we know these two are shorted, so we're going to get our snips. And so what I normally do, I don't have it here in front of me, is, depending on what it is, I'd take a silver paint marker. I got somewhere, I've got a silver Sharpie, but I'll just dot what I find. These two are the bad ones that we were testing. And the reason why I do that is, if you go through, if it was a big bank like on that 200 had a whole bunch of them, sometimes you can figure out that not all of them are shorted. So you would go through and mark the ones that are definitely shorted, and then maybe use a different color, like I got gold there for some of the others that read shorted but not completely. And so you go through, you cut out the shorted ones. The beauty of Rockfords being so symmetry is I don't even have to remember which FET's which, because they're identical for this channel. But we're gonna snip those suckers out. And sometimes on this channel, one FET does all the shorting, but the other FET could have took damage, so we can even check these again here. So that one's already shorted, and that one's shorted. So both of them were completely shorted. We got a 36P 15 and a 40N10. That can be replaced with a 28P 15. And that's probably what we'll do. If we do that, I will probably desolder this one, even though it's good, and replace it with a 28 so it's all matched. Now, when you change output FETs, I know I'm going through a whole lot of stuff. Yeah, I wish they did that, the remote trick for the primes too, Cliff. But the primes are just not a real Rockford amp, in my opinion. They're built for a price point, because they have to. Rockford's got to stay in business and got to, compete in all levels, but they're not a punch or a power, man. They're just not. So, okay, where was I going? Oh, anytime you change FETs, you're going to have to go back in on a Rockford and adjust the bias. That's these two pots right here, and they set the bias. And Rockford on this newer style amp put some goo on it. That's really a pain in the butt to get off, and so you have to be real careful. But we will end up chipping that away and resetting the bias, and you can do that by checking voltage across the source resistors after we check these source resistors, because that channel could have blown it. Or in some amps, I don't have a good example. Some amps have big ceramic block style source resistors, and so you can't get a clip, for voltage on there with it correctly clamped to the heat sink and everything. And so then you have to hook up your meter and stuff and measure current. I'm lucky now I have a lab style power supply that lets me watch the current, so I can set them up that way. So we've got all the screws out there. We've cut those out. We need to get the screws out of the board. Oh, we need to get this front cover off also. Alright. If I miss your question, scream at me in chat. I'll try to get them all, and I know I'm talking fast, but it's so I can try to hit all the questions. Now this cover is supposed to look like this, and that's actually cracked here, and then there's supposed to be 3 tabs that go there. And so what I've done is I've in ABS printed me up some of these, and so when I get them in like this that are broken, I can go in and cut away with the knife and the Dremel tool and stuff, and glue some new little tabs and glue a new piece here, and then I'll reinforce it with some real thin epoxy, let it set up overnight, and then I can make these covers stay on and not fall off when they've been damaged. They, worst part of this style Rockford amps is these little things, because they take a beating and then they crack and fall apart. Unfortunately, but I like to fix them because I'm kind of anal that way. I like my stuff to stay together, I guess. So whatever you decide. Says hello. I'm kind of going way back up into the chat to make sure. How long am I going to live stream? I answered that a couple hours probably. May take a little break in between. We may mute the mic and go to little boy's room. That's always a possibility. I'm no longer young with a 400-gallon bladder. And let's see, we'll get back at it this week. Cliff's got one more. All right. Lift that out. That one stays. That's all that needs to be cleaned up. You can see where just debris and all kinds of nastiness. I always look around for those telltale little wires. Looks like there's one right there, but it's stuck in there. But it doesn't look like we have a bunch of them. You'd just not believe how many amps I get that are killed because guys just keep stripping wire back and swapping amps and stuff, and they all get frayed, and they get that all over their trunk or wherever their amp is at, and they end up blowing their amplifier. So we are going to get this temperature probe up and out of the way. We're going to take this off, this one, and those FETs all look blown. So that makes it kind of easy. Just going to do the snippy snip. It's much easier to remove the FETs, just the legs, than trying to heat everything all up. Every one of them's got their legs blowed off. These are the 75344Gs. So I don't think I have them, and so let me look up here. That would be the HUF 75344G, which is one of the FETs that Rockford picked for its power supply, and then the other one, which is basically an equivalent, is the IRFP 064N, and same amp, different production year, will have the different FETs in it. So Rockford uses the IRFPs, so it's not like you're doing something weird or anything else like that, or making the amp not original. Rockford uses them. Rockford's really smart about picking a couple different parts for almost everything in their amp, just to make it so that if they can get something cheaper, they can. If there's a part shortage, they won't be as affected by it. They got a backup part number that's equivalent, which is really, really smart. See how much nastiness you can clean off the board that's just from those blown legs. We'll get back to this one. Got that. Awesome, thank you. Shoot, when I pass the restroom, I have to stop now. Yeah. What's crazy is that, like, you go to sleep, you wake up in the morning, you go pee, and you do with one of those Austin Powers, pee forever, and your bladder's not tiny, but then as you're working out at your job or whatever, I'm always like, oh yeah, I need to go out and do something or go check something and blah, 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 blah. And it's like, I can just kind of feel it. I better go pee before I head all the way out there away from the bathroom and get out there, because as soon as I get out there and start trying to work on something or take a measurement, I'll have to stop and have to come all the way back and go pee. So we are going to get this set up and turn that on. There we go. So yes, Cliff, by the way, I did get a desoldering gun, and I'm loving it. I'm waiting on the tip for the bigger one to be able to remove bigger legs, but let's go on ahead and get these things out of here. Now, most everything nowadays is built with lead-free solder, which has a higher melting point than leaded solder. So I'm a big proponent of, when I first go in to do anything, I'll just toss a little bit of leaded solder in to help mix with it and help lower the soldering or the melting point. Just seems to make it easier to get it out, when you actually do the final heat to get it out, and it seems to make the holes clean out better, much nicer and neater. So I always do that when I go to take chips off with hot air. Always add leaded solder and kind of mix it in, because then that component will melt first, and it's easier to remove without blowing all the little bitty capacitors or resistors and stuff that are around it off. And so it's really easy to go in with your soldering iron and add leaded solder to stuff to help just drop the melting point a little bit. I don't have this one. This is my new soldering iron that I picked up. It's got more power than my little Heiko. Not as much as my big power one, but my big power one's not grounded, all that other stuff, so you have to be a little bit more careful with how you use it. And so I'm still getting used to this one. I love its quick change tips feature, is the one thing I love about it, but I've not got to use it a ton. That's got to be the big ground plane that we're on right there. Come on, get a little heat in there. So one thing I'd love to do coming up, if I get all my crap right, I've always thought I'd love to have my own business and all that stuff again, and I like doing so much old school and building some of the some of the things that are hard to find anymore. And there's a leg out. I've always thought if I had my own little website where I was selling, like, you know, custom wire and harnesses for the old school Rockford stuff and everything, that I'd also have a map on there with all the repair shops across the country, the good repair shops. Can you send me your Punch 200 DSM for repair? I don't do it for a living, man. I am so backed up with friends and buddies, and then my own that I pick up that I just can't. Someday when I turn it into a business and I try to make it my real job, yeah, I could, but I've got a wife, family, and I got a 40+ hour a week job all the time, so I just can't take in anything more than the stuff I do for local friends. I hate to tell people that because everybody keeps asking me, but that's why I want to put a map on my website of good quality repair places, and I'd love to be able to find somebody smart enough to put it on there where the owners of those repair shops could adjust their lead time. So if they were really busy, they could put on there, you know, they're 3 weeks out, or no longer accepting amps because they're so overwhelmed. I know there's a couple of the amp repair guys that during coronavirus have stopped accepting regular amps from the public, and they're just doing the warranty work for the companies that they've got warranty stuff for. Man, this thing is really fighting me because it got so gnarly when it blew up. So while I would love to say yes, because I'd love to be running my own business and everything else, I don't have all the stuff set up. I'm stuck in my garage. I'm doing this in my garage right now. You know, I need a shop. I need stuff set up permanent. My bench is a mess because I bounce back and forth between fixing computers and game consoles and amplifiers and stuff, and so, you know, I need something that has workstations where the correct tools are there instead of the tools for 6 different things are all crammed on the same bench. Does that make sense? Use my desoldering pump? Yeah, I probably ought to. It's loud as all get outs, but I could do that. Sorry, it was over here on the table. So there is my fancy new desoldering pump. See if that makes quick work. I actually wanted to test it even though I don't have the bigger tip to fit on some of the bigger legs. It's actually due Monday. So, but yeah, let's see if it'll suck that out and how well it cleans that out. And then we need to do this right here. So I don't think it'll fit on those fat legs because my tip is just this, the regular short one. I have it set at just under 2 for desoldering. That's what I found worked on a bunch of the power supplies and stuff I've been working on. So, but yeah, David, one of these days I'd love to have a shop. I'd love to not have to work for somebody else. I'd love to be able to do it, and I love tinkering and piddling, and I've got CNC stuff kind of built, and I've got a 3D printer, and so I'm into all kinds of that fun stuff, and so I really need a shop and, you know, be able to set up and then can take stuff in to fix and fix my own things. You know, I learned to fix stuff because I grew up so poor that we couldn't have lots of nice new things, and if I could find something broken and fix it myself when I was a kid, then bam, you know, I'd have something nice. Yeah, that worked good. So yeah, this does not fit over that bigger leg right now. So I may have to just let it do the heat job. And find my tweezers. There. But it does do a good job cleaning out, apparently. There we go. Nice. Yeah, and you know what? Instead of using my other big old soldering iron that I don't like to use very much, but I had to for all that time because it's not actually static grounded. This is awesome. I just now thought of that. See, it's so great when you get a new piece of equipment and you get all kinds of new bonuses from it. Absolutely fantastic. Good idea, Cliff. Thank you. Somebody's got to keep my dumb self from, or keep me in line. Somebody smarter than me. So, if you watch some of my videos, you may notice that some of the music got changed in it because I thought I had downloaded copyright-free orchestra music. You know, some stuff that everybody ought to... What the hell? Thing's just perfectly rounded to slip off there. And apparently somebody somewhere has copyright on that, and I think it's a bunch of crap on YouTube because I hear about false claims all the time, and so anyway, I had to change out the music. So that's been a pain. So now I'm gonna spend some time finding some good music that I can put when I fast forward in the videos. All right. It kind of fit in the tip. But man, it is always so much easier to me to add a little bit of leaded solder. Just makes everything come apart so much better. Get this thing apart and then we'll hook it up to power and I'll start showing you the waves and stuff and what I mean by that remote setup. Go ahead and turn that off. Make a little room. So let's get all this off here. I still only use leaded solder, is what Cliff says. Yeah, the funny thing is you know, the world pushed to clean up and make things more environmentally friendly by using lead-free solder. And so what we got was a whole bunch of electronics that break and fail earlier. And so people just started making electronics disposable, more and more disposable. And so we actually got more trash and more waste because of lead-free solder than we did saving the environment. Plus, like the U.S. military and NASA and stuff, they will not let you use lead-free solder because it does embrittle too easy and break and cause problems. And so, you know, if there's actual companies out there that go through and take products and desolder it and resolder it with leaded solder so that the military can use it, so that they don't have to worry about the lead-free solder getting too brittle. I know that's crazy, but that's the fact. All right, so let's clean this up just a little more. Trying to keep my glasses from falling off my head. If you wonder what I do whenever I pause for a minute, it's because I'm losing my glasses. I don't have those awesome old lady strings on them. Keep them from wandering away. I set them down and be like, where'd my glasses go? And I don't need glasses normally. I just need them for close-up stuff and to read small letters. Anything that gets close up anymore. Just the fun of getting older. That thing is filthy. Those blew up good. So in removing those FETs, if I turn this the way it was in the heatsink, in removing the blown, what appears to be the blown channel, and removing these blown power supplies, we now have this resistor, this resistor, this resistor, and this resistor. So that is R11 in this one, R1004, R10, and R1003. Should be, I think, around 47 ohms, something like that. Let me look with my eye loop. 51 ohms is what they are. So 47 ohms is what you normally use with the IRFP 064N FET, but that 51s will work. But we got to check and see if we're getting good drive. So one thing we'll notice, we'll get our meter in continuity again. So one side, this is the gate leg right here. So that's going to be the side, the left side of that one. So on all these, that's it. So that means this other side goes through traces and goes to this board right here. And on these Rockford amps, the power supply, you'll see it says AB. Turn this thing off before I burn myself on it. There's a button back here. There it is. Let's see if I can get that to show up. See, it says AB power supply right there. So that's got the TL494 chip or whatever they use. What are they using on these? 494 on this one. And it's also got a couple comparator chips for all the fault protection circuits and everything all built in on it. Smart move by Rockford. This exact same amp, as they get bigger, they still use this. They just get a bigger board for the other bigger components. These are the output driver boards, one for each channel. So you know they can have that. Crossover boards and stuff. So they reuse these same boards as their amps get bigger and bigger, and they just add the extra components to help drive more and more stuff. Smart engineering. But let's get ground wire. Ground on these amps is in the middle. And my remote turn on wire. Dang, come on. These things must have been backed all the way out. And so I can turn on my power supply. Should have had my scope on earlier to get that. warming up. I should have, there we go, it's got my oscilloscope on it. So I can bring up power now, and I have my remote wire here on a foot switch. So I can click it whenever I want. Perry said it's okay to use the 47s instead of the 51s. Yeah, I'm assuming the 51s should work too. I mean, you're only talking a 4 ohm difference on driving that. I don't think it's huge, but I'll probably end up showing that a couple of these are bad. As a matter of fact, I guess while I'm waiting on the scope to warm up, we can put it to ohms. Cliff's going to keep me honest here, trying to focus on chatting, and I'm not focusing on correct repair. So that one's reading 51. That one's reading 51. Well, I'll be danged if these all are okay. That'd be a first time. 51. Normally, when you blow the power supply, it'll also blow some of these and cause a short and go back. And if I get my pointer right here, the drive transistors coming from this TLC 494, which makes the pulses to drive the power supply. These are the drive transistors in here, and normally it'll blow a couple of them, and you'll have to change those out. There's this one, that one, and that one. That one's a diode, and you'll have to replace these because it'll fry these also. But we may end up with good drive signal here. So let's do that. Going to hit the power, and I didn't see the current jump to the moon, so we can just look right here. Ooh, it does not look good. It doesn't look terrible. Of course, it's unloaded right now. It doesn't have a FET in it. But this is the square waves for each of those. And so you can see that overshoot here and here. If I can zoom in more, I don't, there. That could go away. Other things can be caused when the FETs go in, but technically we've got what looks like a decent drive. That's the square waves. There's actually two of them. They pulse back and forth. One's shut off when the other isn't. But let's see. I don't want to bump the camera here. I'm trying to get to my drawer. Do not have them in there. IRFP 064N PBS. I knew I'd got some in. So these are all going to be batch matched, but I'm going to double check. And what I mean by that is there is date codes on them. So you can see the part number, and then they say R, and then they're going to have like P038D or that 82 or 3. Those should all match if they're all matched batch. And it's going to be important that 2 of these are matched and 2 of these are matched because they are actually technically in parallel. The circuit board actually is making them in parallel. Well, everything but the gate. But if they're not matched, then one of them could be slightly different than the other, ever just so tiny. And whichever one has got the lower resistance or whatever, that will end up being the one that does too much work. compared to the other one, and which will cause them to fail faster, and that's why you always match them. So if this was a bigger amp and had match sets, you know, I had like 4 of each of these for each channel, and even if only one of them blows, you got to take all of them out and match them, so that they don't, so that they heat evenly and they all match and they all get driven the same also. So to do this, my cheaty way of making sure everything is perfect is to bring the heatsink back, and I actually just stick the heatsink in there, put a couple screws, hold them up, and I'll solder the gate leg. But we need to clean a little of this up before we do that. So let's get some rubbing alcohol. I finally found a little bit of rubbing alcohol at Walmart the other day. I was getting a little worried that I'd be completely out due to the pandemic, and I wouldn't have any, and then I'd be, I mean, I can use acetone, but acetone's not as safe around painted finishes and some cheaper circuit boards, so I like IPA, safe for most everything. The higher the better. I use 91 for general cleaning. You got to be careful though, that does still contain 9% water. You don't want to overdo it on a board. So we're not trying to finish clean these to make them perfect for final reassembly. We're just going to be doing it for getting it cleaned up for measurement's sake, and I will clean all this off camera because nobody really wants to watch me clean. So we need that pad to go back on there and match up its hole. We're going to set this back in place. And grab a screw or two to make sure the board's aligned properly. This is the way I do it. Other people may do it a different way. I'm not saying this is the right way or anything. I'm just trying to keep it all square and looking good. So the board looks pretty good there. And then I'll just take the fets and drop them in place. And they're going to fall down. They're going to go too far. But the gate leg's always easy to add a little solder to. So, soldering iron wasn't stuck. Get my solder out here. So the gate leg is always that far left leg if you're looking at it. And so, I need my tweezers. And so I'll get some solder on my soldering iron. Clean it up into a brass sponge, brass wool, I guess. We'll get a little. We're going to go in here and we're going to get a little on that there pad and that leg. Once it just starts to heat up, we're going to lift that fet up into the correct position, and then remove the soldering iron and wait, and that'll solidify. And then when we take the board back out, we can solder it from the underside perfect and get all the other legs. It makes it look nice and neat. They go right back into the factory spot. Then you don't need much, just enough to hold it there. and bam, they're held in place at the right height, because I was using the old pads to kind of set it. Oh, I take the screws back out. Duh. And so everything will look nice and neat. And that's right at the edge of where that leg is going to be, and so actually I'm going to lower them just a skosh, because I like it right there. That's okay where it's just barely sticking through, but these are a little shallow, so I can always take it, get a hold of it with my tweezers. Now that I've got the angle all set and everything else, maybe get a little solder on my soldering iron so it'll conduct a little heat. You guys can see that. Let me move that back a little here. Scream at me if you can't see something. That looks a little better. I'm a little happier with that. I'm going to readjust it just a little. Right there. I want plenty of leg through so I get solder on both sides. There, that should end up fitting nice. Well, now I can come in here and I can solder in the other legs. And sometimes you got to get fiddly. More important on amps with mesh strips and stuff to have everything perfectly aligned. I think that's why Rockford went to this design with the back plates that are just there and stuff. It gives you, man, it just gives you a huge room for error, and everything's still very well insulated and still positioned perfect under the clamps and stuff. They built in some really good tolerances. But I do like to try to make them as even as possible so it looks factory. And so that it looks nice. I'm purposely going from one fet to the next to reduce the amount of heat I have to put into each fet. Center leg's always going to be the hardest because it's the one that's connected to the back metal plate of the fet. So I don't know if I explain that well, but I'll take a brand new one here. For those who don't know, the reason why it's important to have those insulators on the back is that the fets and transistors, both, that have a metal back. Let's bring the meter in here kind of where you can see it. The center leg is electrically connected to that back metal, and that's why it's got to be isolated in a lot of amps, because otherwise you're putting that center leg that you're going to put voltage through into the metal heatsink. So let's go back to soldering. Alright, nobody else has said anything, or my chat has locked up. And if my chat has locked up, the only way I'll know is if Cliff texts me. did get a notification that my thing's sold. My power supplies that I'd refurbished. It's good. That'll help make up cost on it if you've watched my PS4 power supply videos that are slow but sure coming out. Oh, you was going to pick up your relief. Well, nobody else had asked any questions, Cliff, and so it got real quiet in the chat. And so I was hoping that like the chat hadn't locked up. This is the first time I've live streamed with my different computer when my old computer died. So this one's Linux, not Windows, and it has presented its share of challenges as I learn all the things again in a Linux environment. That's just because I refused to go to Windows 10. It's just invasive. I don't need it. Everything's open source now, or on the web base just about, so the only people I know that really gotta have Windows 10 are either stuck with Windows because they can't figure nothing else out, or it's because they video game. And everything I video game is so old that it don't matter. Alright, those solder joints look terrible from that side. What I'll probably do is end up putting some flux there and feeding a little solder from the top, because you can see they just look gosh awful. That's where a little bit of that carbon was. You can fix that though. More videos to come out, but I am still waiting on a few parts to finish all that and stuff. I didn't think I was going to end up waiting so long on some of the parts. They got delayed. So, it happens. That's why I, like on fixing these amps, I waited until I had some more parts in. Because I'd ran through all of them. Just crazy. Lots of shipments getting delayed right now due to COVID and supply shortages and stuff, so you think you make plans and then those plans go south. Oh, and thanks Cliff for that tip on don't use a whole bunch of flux when desoldering with that solder sucker, because it gets in there and turns all sticky. That made a lot of sense. Oh, and it is about winter time, so I have got to fix my fume hood setup that I want to be using. That made those look a little better. So we will go back to put some power and get the probe. And now that we got 4 fits in, when we look at the gate, let's see what it looks like now. We'll just grab that leg. See how that waveform changed? It got a little smoother and a little rounder at the edges and stuff. That's due to the capacitance of the FETs changing the way the drive circuit works a little bit. But they all look good. So now, when you power up amplifiers out of the heatsink, you have to be aware of some stuff. If it's a Class A/B amplifier, which is what this is. The bias is setting those output transistors kind of on. The bias setting turns these transistors that are on the output slightly on. It's like setting the idle on your car. And so it idles them up. For a Class AB to work, they have to be a little bit turned on, actually, just setting at still. And so what that means is that outside of the heatsink, Class AB amps will start generating heat in all their output FETs. So I just hooked up the B+. If I was to turn this amp on, it's going to do that. So a couple things you need to do. Class D doesn't do that per se. Now, there may be some out there that does, but Class D, because it's all switching like a power supply side, doesn't have an idle. You know, it doesn't idle up the outputs. So these things can get hot really quick and overheat, even though you're not playing any music, just because you're doing it. So when you work on them, you either have to be hyper aware of that, because some of them overheat faster than others, or you have to put it back in the heatsink. So we're only going to look at this really quick, and we'll give it plenty of time to cool in between. So you've seen the gate. There's the gate drive. Oh, and I don't have, even though I got the power wire hooked up and I'm turning it on, I actually have this power wire has got a inline fuse. Let me kind of show you. Here's half the holder. I've got it unplugged. Oh, the dog needs out. Okay, 3-4 minute break so I can let the dog out and in real quick, and I'll mute it. And oh, my wife's getting it. Never mind, I don't have to. Go ahead, Ellie. Go potty. Good girl. Okay. Thanks, Cliff, for watching, Cliff. That's Cliff. It's strictly amps. He does some amp repair when he has time. He's like me, has a full-time job, and so he's down in Georgia, I believe. So he has to limit the amount that he takes in, just like I do. I think he actually does a few. He actually started a business and actually does it for a few of the shops around there. So, but he's got limited time like I do, so he can relate. Last week in the 70s here in Chicago, now in the 40s. Oh man, it's been like that down here in Springfield too. It's just, it was beautiful. It was like the beginning of this week is beautiful. I don't know if you guys can hear the rain outside of the garage, but beginning of this week, when I was at work all week, it was beautiful, 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 beautiful. I'm stuck at work now. I get time off, and I got a few chores I need to do outside, and it's raining. So, okay, so we're going to power this up, and look, it comes up blue, no protect. That's the drive wave under power. You can see that on the scope. Here is the big drive wave on the power leg. Looks really good on all of them. Alright, so we're going to turn it off, and then I'm going to feel these and make sure they didn't get hot. And so that's about as long as I want to run it. They didn't get hot or warm, but they can and they will. So now that we got good drive and we're generating, we need to turn our meter to 200 volts or so here. And on this back panel here, this is a diode, this is a diode, this is a voltage regulator, and this is a voltage regulator over here. These two voltage regulators should be making the plus and minus 15 volts for all the opt amps. You can see opt amps down in there, and there's some on these cards. That's for the input signal processing to go out to the output stages here. But on these diodes, we can measure the rail voltage when we power this up. And the rail voltage, peak to peak, full voltage is 70 volts. So it should be plus 30, minus 30. And so we can put this on the negative side. Or 35, sorry. So there's 34.9, and on this one, negative 34.9. And that makes our rail voltage for our music, for the output section, to swing back and forth in a sine, music sine wave type thing. So it can move the speaker forward in the positive rail voltage and move the speaker backwards in the negative rail voltage. So the power supply is up and running. If I shut the power off, I'm knocking stuff off here. And we bring our heat sink back. And we put that back there where it's supposed to be. Drop this into place. If I can get it to where I know that the outputs are not gonna get too hot here. So we'll put a couple screws in the board. I've got my power supply off by the way, so it's like it's unhooked, even though you see my wires here. Alright, that'll keep that from moving, and we're going to clamp down this one output. Kind of jerry-rig this in to keep those from getting too hot. So I would look at the front face, and we're going to need, the input is on the bottom here. We're going to give her a test. The one working channel anyway. So we'll have that there. Now I'm going to go, and this is the filter, and I'm just going to work that switch back and forth a little bit. I'm going to put it to all pass so we can hear it fully. And we'll get a screwdriver, and we're going to work this pot back and forth. This is the punch EQ. I'm going to work it back and forth a little bit, and then I'm going to turn it all the way off. And then on the crossover, I'm just going to work it back and forth. And I'm going to set it at about 125. So if that was there, about right there. And we'll test just for the low pass there. And then on this is the gain. I'm going to work it back and forth just a little bit to make sure, and we're going to test these for scratchy is what we're doing. And then I'm going to set it to the middle point because I know that works good with my head unit. So that's all good. Since we only have this outputs in, we're only going to get power out, or sound out of that speaker side. So we should crank this on. And turn on the power supply. I'll turn on my radio. My mess of wires out of the way here, and we're going to turn it on. And now we will go. Can you guys hear that? I've got super low still. My dog's wagging her tail to it, that's for certain. No, Ellie, sit down, please. So one of the things we can check is bass boost. There was that. We can check the gain back and forth. And what I'm doing is I'm listening to see if it makes scratchy sounds, so we know how that is. Now, if we select it down, it's high pass. We're not going to hear much difference here. Hang on, let's wait. Let's do low pass. Low pass is going to take all of it out. So that's just lows. That's high pass. And that's all pass right there. So that channel's working. We got the power supply back up and working. I'm going to turn her off there and kill the power. We just have to either fix this channel and see if we're going to match. I don't know if I have any of those. What were they? 44N10s. I don't think I do, so I'm going to end up having to take that channel out. So some of the things you have to check on a Rockford when you fix that channel is whether it blew the source resistors, and then there's a protection circuit. So the protection circuit should do this. Actually, I can, at moderate listening levels, I should be able to show you this right here on this one. Turn this back on. Start playing a little bit. So at moderate listening levels, the protection circuit works really good. But man, you got the amp cranked, the gain cranked, you get a blown woofer and stuff, and you know, just the protection circuit sometimes just can't react fast enough. It just happens. But let's see if I got this back up and working here. Be careful. So you should be able to, if the protection circuit's working correctly on an amp, on the Rockford amp. Where's my, here we go, a little bit larger tweezers. Short out the speaker output, if I can get to it on here. I gotta make sure this, yeah, okay. So I'm gonna get in there. So their newer ones don't have access on the back like the older ones do, so it's not so easy to get in there and short it. Maybe foolishly attempting. I was wanting to leave it while it was playing. Let's see if I can get in there. My connectors make it to where it's really hard to get to it is the problem. I'm not getting to anything there. And these are coated with paint on the top, so that makes it really tough too. Should be able to do this. There we go. Now you notice it's not in protection, but it stopped playing. And when I go, sometimes it will. And what Rockford's amps do is they activate a mute circuit to turn off the output transistors to protect the outputs if they get shorted. And so that's exactly what that did. Now, it works at regular listening levels. Like I said, you crank it up, you really got the gain cranked, you got it maybe close to a hard clip, and then all of a sudden a really low ohm subwoofer load goes really fast. The circuit can only react so fast, and if it's already under major strain, you can still blow the outputs, which is probably what happened on this side. And then when they shorted, I'm assuming the person that had this amp before did not have it properly fused, and before it could shut itself down, it took out the power supply. Now, I've also seen people that's blown the outputs before, blown their fuse, and then they stick a bigger fuse in, and in the time it takes for that bigger fuse to blow, it blows the power supply. So that can happen. But that's a proper working Rockford protection circuit. Like I said, it works at regular listening levels. When I replace these and set the bias and everything, then I'll have to test it, and there's a few resistors you can test also. Hopefully you guys could hear that. I wasn't thinking that that music was playing in the background. I will kick the power off. But so my next step on this would be to repair that channel and double check the protection circuit and test it and reset the bias on this, at least if I repair this channel. If I change this transistor out to match, because I'm pretty sure that one was, for here is a 36P15. So there's the 36P15, and I don't have the others, so I need 28N15, so I got one new one there, but I'm pretty sure those are 36P15s. Oh, I'm going to be so mad if that's the one that was held up. Those are 3415s. Oh, 3415s, those are for the BD amps. The 36P15s, I got another box of them. I may have to wait. I got some that got held up. PCXs, those are the 640Ms. Pull another box of the power supply ones. $250s. Well, poop. More 3615s. I got all my 3615s, but I didn't get the others. Now, I did. Where'd my one box go? Ah, here we go. I did get. See, I got a pair of 4615s and a pair of 3615s that are brand new that are in here. And therefore one of the 4-channel amps that I got. So I knew I had that. I thought I had my 28s in, but apparently I don't. So until my 28s come in, I can't finish that little bit. But it was a good power supply repair. It was a good example of the output circuit, talking about matching it and what you have to do for bias settings. So I'll put that back in there. Dadgummit. If you're wondering what, like I got all these new ones in here, if you're wondering what these ones with solder, these old ones are, these are known good used ones. And sometimes when I'm having a circuit that's giving me trouble because other things are blown or the drive and stuff, and I don't want to risk brand new ones, I put the old ones in to do my testing and my probing and my part replacing. So if I screw up and blow something, it's going to blow one of those. If I don't, if I get it all working and these have been, and those are good, then I can put all my new ones in, and that saves me the cost of new ones, because some of these stinking FETs are expensive. I think it's the 36P15 that is the most expensive out of all of what the Rockford uses, and so it's pretty crazy. If you, especially if you have a pretty good bank of them, you know, 4 or 5 of them in one bank, it can cost a chunk of money real quick. If you accidentally did something wrong and you blew them all up. And because I'm not a Rockford engineer and I'm still learning all this, I like to play it safe and put some used parts in when I start having problems. And you know, if I screw something up and I blow it, at least it was used parts that were known good, until I get the circuit all right, and then I can put all the new ones in. So we know those are bad. But we're kind of at a stuck point because I don't have my 28 P15s. So, unfortunately, we're going to the bag again. Let's look at the old school. Maybe I'll have all the parts for it. That's really disheartening. I thought I had them. I had so many boxes there, I thought they'd came. My apologies. At least we did a power supply and, like I said, did a demo. And I'll still need to on this one to check these source resistors to make sure they're good, because a lot of times when you blow a channel, so much current's going through it blows that, and that's what also ends up killing parts of the... When these blow, if these are blown, almost always the protection circuit has something damaged in it, unless the person had it really fused right and all that other stuff. But if these are not blown and only the FETs blew out of it, and so it got, you know, fuse popped, or it got, or these blew and took the fuse out without burning these. If these are okay, it seems like the protection circuit normally survives. But you always want to repair the protection circuit, because this amp may not be running full tilt. It may be running door speakers and tweeters, and if one of them shorts and dies because it got water in it, you know, or something like that, you want the amp to shut that channel off so that it doesn't damage the amplifier. When running on subwoofers, it seems like is when they get killed the most, or big mid-ranges, or like 6x9s, stuff like that. Things that people crank the voltage or the volume way up is what really gets beat. So I'm going to clean this off a little before I bring the other amp. We're at least going to look at it. I don't know how long I've been streaming. I'll have to look. An hour and 35 minutes. I said I'd go a couple hours. I'm going to have to take a quick break. So we have a Punch 501S. I don't know anything about it. I've never looked in it. Oh, there's somebody's info on that. I don't want to give away people's info. I know whoever owned it before had popped the cover off. So let's just investigate. That's a beautiful looking amp. I don't see any damage in here. Looking around. These kind of caps that have the black plastic on top of them instead of open silver like this, a lot of people will look at those and they'll get bulged up, and they'll think the cap is bad because it's like the aluminum's bulged underneath here, and everybody knows, oh, that's bad caps. No, you'll actually push down on the center of them, and it'll smash back down, and you'll feel the aluminum underneath, and it's flat. And if you don't believe me, you can always take a razor knife and cut this shrink wrap off the top here and pull that cap off, and then you'll see the top of that cap is smooth. But you need to push and make sure you feel them all flat, and then they're not bulged. And those look like they got a littlest bulge to them, but you know, they feel flat. That one maybe not. I don't know. When in doubt, if you can't smash it down, you get a razor knife. And you can carefully slip it underneath here and cut the top part of the shrink wrap off so you can pull that off and check. And then you can dab a little E6000 on there to glue that back on. They use bigger caps like this that sit close to the metal plate because the top of the cap is actually part of the electromechanical construction of the capacitor. That's why they put these caps as insulators, to keep a spark from jumping. So we got... Maybe somebody has resoldered the remote turn-on lead. It's a little dirty right there. Got some dust and dirt around there, but nothing too awfully bad. Let's just see. And so, if I remember correct, we will verify here. So, it is remote, B+ and ground. So it's remote, B plus, and ground. So B plus here, and that is the caps. We're watching charge. Oh, you guys can't see it because I need to change my view. To that. So there, it charged up, and that's these 4 caps charging for the power supply. So on this style of amp, and this would also include the black and grinds and stuff, because they're all using the mesh strip type system, and they're all real similar. Your power supply comes in on this one end, so you can look, and this is using IRF 3205s, and it's got 1, 2 here, and 1, 2 there, and then it comes up to the U1620R and the U1620, and so those are the rectifiers, and they're going to, this you'll see on the board, it's labeled CR2, CR1. So this is the power supply. These 4 FETs switch this big old transformer. It's rectified here, and when the AC that this makes is rectified, these caps provide the smoothing, and that's the rail, makes the rail voltage, just like we showed in the other one. That gives you your plus and minus voltage. And then these are, I'm trying to look at the part number here, 337, that's an LM337, and this one should be an LM317. So that's the plus voltage regulator, that's the minus voltage regulator to make the plus or minus 15 volts to provide the voltage for these opt amps in the preamp section. And then after that, these, like I said, I got glare here, IRF 540s, 1, 2, 3, and then these should be 9 540s. Yep, they are. So then for each channel, it's got 3 540s and 3 940s, and that's the same here and here, and that's what produces the output here. And so you'll find 540s and 940s. One of them's a PNP style and one of them's an NPN, and that's one side does the positive half of the waveform and the other side does the negative half of the waveform, running off the positive and negative rail. So I just go through and I check every FET. Now remember I said the back metal tabs are the same as the center leg, so that makes it pretty easy. Now watch this meter. Oop, the beep went away. It's charging them caps. It's going to do it the back of the opposite way too. That's why I said if you get it and it doesn't stop beeping, then it's bad. We're just going to check all these, and it depends on the way you put your thing in, which way you put your probes. Because this, in diode check mode, this probe is your meter is putting out 3 volts or under. Depends on the meter. This is the positive, this is the negative, just like it was a battery. And so we're going to go check the FETs. It always worries me when you get a bad amp and you can't, that's not a beep, you can't find nothing wrong in your initial checks, because then it means it's going to be something sneaky and can become a pain in the butt. So I don't see anything there, so technically we should be able to power it up. You know, when somebody starts having problems like that, it starts worrying me that they got the positive power wire or something brushed against an RCA and have blown out part of the topaz circuit, which is probably right here with this diode, that cap, and that resistor. Maybe. I'm just guessing. I'm not an expert on all these, but or you'll have some other problem, you know, distortion, noise, stuff like that. Sometimes it's as simple though as bad pots, because you know you can't adjust things like that. So it all just depends. I don't see any wire pieces in here, Oh, I see something right here. Is that a wire piece? Or is that just a... I think that's somebody's nose hair. So that all looks good. Other things, you get a amp like this in, and let's say like we hook it up here in a minute and it all works. It may work just fine on the test bench, but then I need to put it on the load and do some testing, and I'll need to be like adding some vibration like it was in a car and stuff, because if there's cracked solder joints somewhere, that could be what was causing the problems. You know, a lot of these I get in, some of my buddies will be like, oh, I can't remember why it don't work. It's sat on the garage shelf for years, you know, and so that's just what I got to go with. So sometimes you have to simulate it, and then other times I've given them back to buddies and said, I can't find nothing wrong. Stick it back in your car and play it, and when it starts doing something wrong again, let me know what it is. Maybe you can give me a better description. Maybe that'll jog your memory. We talked on that other amp about bias, setting the bias for the outputs. That's the same in this. You see these two pots here. However, in this older amp, they didn't put the goo on there. Don't ever go in and turn those pots thinking that you're going to get more power. That is not what it's doing. Remember, I gave you the example that it was like setting the idle. You know, if you set the idle up in your car, that doesn't make your car go any faster. That just actually wears it out faster. What you'll actually do is set it too high, and you'll make these all overheat and kill your amplifier. So these are not some secret place to make more power. That is not what they are. They're setting this up for, they're setting slightly turning the transistor on for proper class AB operation. I'm not a electronics engineer with a music design background and everything, so I'm not even going to attempt to explain the nuances of class AB to you. There's other YouTube channels that can do that. So, but let's go on ahead and be crazy, wild, and squirrely and see about powering this thing up. It may be one of those sneaky little problems in here, or we may have other issues and stuff. My dog cannot decide if she wants in or out. She doesn't like it because it's raining outside, but she thinks she wants to be in or out. So one thing I am going to look at, let's get a crossover, so we're going to want to put it on all pass. We're going to, before we even do anything, we're going to want to make sure the gains aren't too high. Ooh. Well, I can tell you what may have been the problem. The gains are cranked all the way up. So, we will set the gains in the middle. This is the crossover frequency, and we'll set it at roughly 80, 90 hertz. We said all pass is in the middle. Yeah. So let's see what that does, but I got a funny feeling this thing's going to have, it either was blowing fuses because they had the gains all the way set up, or something else happened, but we'll see. So I got to flip it over. And these older Rockford amps all use standard Allen screws. Just so you know, if you go into the hardware store to get you some new screws, they are standard size on the speakers and the power terminals, and for the big power blocks on the power series of these. So I'll show you one other thing I do to rig up on my test bench. I'm unplugging my remote wire, so you can see it's zip tied together here, and I got two banana plugs, two different wires. I can plug these into my actual remote foot switch, but on the other end, depending on which one I have, I got this one that I can put into regular terminals, and then I got this other one which slips on to these spade connections. I can plug in so I can power up these Rockfords. So I have this ready to go. I have the fuse to go. Now I'm lucky because I have a lab style power supply, and if it overcurrents, it's going to limit it to 3 amps and it won't blow anything up. But I don't see it overcurrenting yet, just with no signal to it. I'm not putting in the signal yet. Here, when my thumb kicks out like that, that means I've put my foot switch down to try to turn the amp on. But so right now I'm not getting any current draw, so that's good. That means nothing was dead shorted. You know, we kind of checked that with the multimeter. Now I'm going to get my foot on the foot switch, and we're gonna push it, and I don't see that lighting up. It's drawing 2.26 amps. This should be lighting up. That is this right here. Well, I can tell you that was in backwards already. Somebody's pulled it, and somebody's got a hot soldering iron or something. You know what? Somebody's had this unplugged, and somebody has resoldered this remote turn on, and they got their soldering iron against that right there. That's funny. So the only thing that may have been wrong with this originally is the remote had broke free, and that's really common on these. I like to put a little support behind it and glue it all in so that they don't wiggle and break. And then they may have plugged in the light backwards so the LED didn't light up, and they may have thought it didn't work. So I'm going to turn off this overhead light so we can see a little better. Alright, see if I can shield the light a little here. Can we get it where you can see it? Maybe. There it is, the Rockford lit up. I'll bet this amp's okay. just a guess. So let's go ahead and flip it over. Besides the fact that whoever had it beforehand had the gains cranked all the way up, you know that's going to drive it into clipping when they hit something wrong. Gain is not a volume knob. Okay, I will put that on, and we'll get this. So I got my speaker wire here. We're just going to hold them onto here once I get some music playing. And I'll turn the overhead light back on. Does that make too much of a glare? Maybe. Oh, I just heard something click. Oh, it came on. I did hear something go, so we'll have to pay attention. Okay. Make sure we're in here. This is the volume it should be at. Right there. Let's get it playing a little bit because I think this other side's got an issue. No. Man, if I could hold these a little better. I think it's playing just fine. I'd say, kill my power here. I'm going to say, since the age of it is and everything, I'm going to take it apart, double check their solder joint connection here, make sure this is all right, check the thermal compound, look for anything on the bottom, you know, stray wires or anything. Double check and make sure that the RCAs are in good shape, and recondition them, tighten them up if needed. The one last thing I want to show you on these older Rockfords, and a lot of Class AB amps. Remember when I talked about the Topaz circuit, and that is a differentiation between the ground of the signal. That's part of all of it. It's not everything. And the ground that the amplifier uses. And so if you put your meter on, in mine, we're trying to look at about 1,000 ohms. Hello, Frank. Yes, the Rockford Power Series, the newer ones, awesome. So let's see, I got some more chat here I need to look at. Is that a Heiko desoldering gun? Yes, old school. That is it's the new version. It's the FR301, and I just got it not too long ago. Been wanting one for years, and finally got it and have started using it, and really have been enjoying it. Only problem I have so far is that I bought the most basic one, so it didn't come with any extra tips, and I got a bigger tip for taking bigger FETs out, but it's not going to be here till Monday. So order a bigger tip when you order it. So yes, Frank, yeah, I love the Power Series. I've been putting together a modern Power Series collection of, I fixed some amps and I fixed a T0 power sub and stuff, and that's going to be the build for my wife's car. So anyway, we're looking on these older amps. Modern amps won't have this because they have a balanced differential style input that doesn't do this same thing. But there should be resistance between the outer ground RCA shield and the ground wire of about somewhere between 500-ish and to 1,000 ohms depending on the amp. Rockfords are lower, and what we're reading about 480. And what that's reading, and if I turn it the other way, it should read 1,000. If I put the negative on the other side, or close to 1,000, we're at about 800 and something. It's charging that little bitty cap that's in the Topaz circuit, and so it should jump up maybe to a full 1,000. Remember how I say that matters. The Topaz has a diode in it, so that it does matter about it. You're reading the diode one way, and the other way you're reading the resistor and the capacitor together. Yeah, old school. Pick up one. It has already made my life so much easier. Have a good one. Be safe there, Cliff, otherwise known as Strictly Amps in the chat room. And so you need that. If you was to take that reading there, and that reading was, say, it was 0 or whatever, that means that somebody has probably touched a power wire or an active remote wire or something to the shield of the RCAs. Maybe not on the amp. It could have been up at the head unit. It could have been at the other end of a pair of RCAs, you know, because they had it hooked up, and that blows that current passes to ground, and it pops that little circuit. Well, that's part of the noise rejection circuit. Oh, excuse me. Part of the noise rejection circuit schematic set up in all kinds of amps. Most of these old ABs at least have resistors between to float the input up above a little bit from the vehicle's ground. Rockford takes a step, several steps further with their Topaz circuit, which floats it plus moves their plus and minus voltage on the other side of that Topaz circuitry to help keep cleaner power to it, to help keep like alternator noise and other interference out of the preamp and the amplifier section. So that looks good. So sorry guys, not much else I can do besides take this one apart, give it a check, probably put new thermal compound, because I'll bet the thermal compound, well, it's not too terrible, but it's still a little dry. So this one's in surprisingly good shape. I am going to, like I said, check that because it does look like somebody else has done it. I'll put my reinforcement to it, fix this up where they've kind of hit that, make sure nothing else is wrong, and then I'll give it a hard bench test. I'll clean all the pots and switches would deox it. I always do. A good tech will, just to make sure it all works, make sure everything's all in working order, and give it a hard road test to make sure it doesn't do anything weird. Because you know, sometimes you get what appears to be, like I said, I'll have to go in and I'll bang it. I thought I did hear a little pop when it first fired up. I don't know what that was or was not. There is some fluff junk down in here and stuff, so you never know. This one's more caught with, if there's anything wrong with it, it'd be weird. You know, it'll be wire strand underneath there or something like that, or it's going to be a broken solder joint because somebody mounted this to a box or something. So, but that's pretty cool. That one was good. Well, 2 hours, and all I really got to show was a power supply repair. I will double check on my order if that thing's going to come in, if those aren't so delayed that they'll come in before next Saturday, you know, or whatever. I may save the rest of that amp and make sure I do another live stream next weekend. But I'm going to put this one up. We got, I can't remember, oh, the first one I got to do all the cleaning to and stuff. So I'll see if I can dig through the pile and find something else fun. Maybe something I definitely know I got all the parts for and didn't get sorely disappointed. I do have an old Zapco amp that I want to do, and then I got a few bigger Class Ds that I need to do. So we'll see if I can't get a live stream in. Leave some comments on this, on any of my other videos. Put questions on there, man. I'm just yeah, Frank, this thing is beautiful. It's in beautiful shape. As a matter of fact, on the outside, it's in beautiful shape. If I was to, you know, that's why I got a silicone pad down, is I don't want to be the guy that tear up somebody's amp. But if I was to just do a little of this and actually wipe the thing down, I mean, there's not a scratch. The only place there's any scratch to the finish is where the screws are. If a fella happened to own, give me a second. I don't know where they went. I thought they were down here, but apparently I moved them. I have a pair of the correct end caps, but they're going to go on my, oh, that's still dirty. That, but right there, if I took a little rubbing compound, it looks like that got a little, it's not even a scuff. You can't even feel that, and that those are sticky. So probably before I'm done, I'll take a little polishing compound, and that thing will be perfect because it's in really, really good shape. See if you can see that there. That tiniest little nick will come right out, and it'll look fantastic. But I will live stream some more. I really enjoy it, and I hope to get enough viewers to ask good questions. Just like with, I think it was Dave that asked about the 200. I'm getting a heck of a collection of dead amps. So I may have an amp that's similar to what you are, especially on old school. I try to collect a one of kind of most designs. And I just scored a few. I've scored my first old school Phoenix Gold. I got another Linear Power. Those have been really hard to come by in my area. So, man, thanks for chatting with me, guys. And you know, like I said, if you hit the subscribe and the notification, you'll know when I live stream next. It's getting to be winter, so I've got one more weekend worth of chores I really have to get done outside. And after that, I'm probably going to be in the garage with the heater on when I'm not, you know, with the family or at work. So I'll try to get in a few more. Leave in the comments of this how long you prefer a live stream to go on. Do you like them short, like just a quick hour? Or do you like 4-hour marathons or what? Because some nights I'm out here until the wee hours of the morning. I could always live stream whatever I'm doing. So Phoenix Gold used to be the cheapest cheapy brand. Well, actually not. The original old school Phoenix Gold was really good, high quality back in the days of the cheater amps and stuff. And then when they got bought out, the company that bought them out used and abused their name, made a much cheaper product, and kept cheapening it up for a long time, and just kind of rode the name into the dirt. And so, but the funny thing is that supposedly what I heard is that they've came back. They've decided to rebuild them as a real high quality amp now, and so the Phoenix Gold may be making a real kick butt comeback. I don't know. We'll see. With the heat sinks on one side. Well, Phoenix Gold, Zapco did that. This is an amp I was just talking about. I've got a Zapco 150 or 250, something like that, a little AG. And, it doesn't matter what your heat sink looks like, as long as the engineer that designed the amp did the calculations for how much heat at its rated power the FETs were going to dissipate, and then that depends on your heatsink design and mass that you need. And as long as you get enough mass and enough cooling there to cool off what you're making power for, it doesn't matter. So that technically back in the day, everybody was more creative with their heatsink designs. Nowadays, with all these all these cookie cutter Class D amps that all have the same board in them. There's like 4 heatsink designs, and then they just engrave everybody's name on the top of them. So there was, back in the day, it was cool. You could immediately tell a Rockford was a Rockford, a Phoenix Gold was a Phoenix Gold, a US Amps was a US Amps. You knew what an Orion looked like. They all had their own heat sinks, and then Rockford came out with a different design, but Rockford has definitely been one of the ones that has always had unique heatsink designs for so long. So really cool. Yeah, thanks, Old School. It is cool. They are cool old amps, and I enjoy working on them. I enjoy learning about them. So, guys, I'm going to get out of here. I'm going to go check on my puppy dog here. I think she's needing a little love. And then go see what the wife needed. She kind of waved at me. So I appreciate you watching. Like, comment, subscribe, ask questions, and all that other stuff all those other YouTubers say. And like I said, thanks for watching, guys. And maybe tomorrow or definitely by next week if I get some parts in, and I want to do this more. I just been really busy. So thanks.